Okay, so here's some integration. Now each time we look at an expression, we've got to decide, what's the technique that we're going to use to integrate it. And there's a big checklist of things to do. Can you just do it as a polynomial integral? That means maybe expanding a bit of brackets first and tidying it up. The second checkpoint is integration by inspection. Can you guess the integral so that when you differentiate it, you get back to the original integral? And then it's just spotting, what might work, what might not work. And the key thing here is spotting. Can you see the two functions side by side? Is one of the functions the derivative of the other inner function? Okay, let me explain. So for each of these, I'm going to do the left hand side 1, 3, 5, 7, 9. I'm just going to explain briefly, then I'm going to just do 1, 2, 3, 4, those 5 questions and see how long it takes. Okay, so we're looking now to see if the inner function, so this is the inner function powered up to 2. This is the inner function powered up to the half. This is kind of the inner function here. This will be powered up to -2. So I'm going to rewrite each of those, okay? And I can see that 2x squared plus 5, the first one, the derivative of that is 4x. 4x appears here. So any kind of kx that appears there, it means we can do question 1 by inspection for sure, okay? And look at this inner function, 3x squared plus 5x, the derivative of that is 6x plus 5, there it is. We can do these instantly on site, okay? This one here, x squared plus 3x plus 1, the derivative is 2x plus 3, appears there. This one here is 6x squared, and this is 1x squared. See, so it's kx squared, so that's fine. And here, notice I'm choosing the inner function as the one that's got another thing going on. This is a composite function. This is f of g of x, essentially, okay? So what we're looking for is f of g of x, and then the inner function, the derivative, g dash of x here, and then a k, some kind of multiple of it, alright? So let's take this last one. Here's x to the 4 minus x squared is g of x. That's wrapped up in a cube, so the f of x is x cubed, and the derivative of g of x is 4x cubed minus 2x. And if you notice, this is just 2 times by 4x cubed minus 2x, okay? So that's k times by g dash of x. Right, so I mean we know those guys are actually integration by inspection. We know they can be done because the questions told us that, but let's just see how quickly we can do it once we recognize what the technique is. All right, and then I'm going to do it by using substitution, which I showed a few of you today. All right, so off we go. So question 1, I'm going to write down the 4x part, which I'm not going to deal with at the moment. I'm going to multiply by that by the integral of 2x squared plus 5, increase the power by 1 to give 3, divide by the new power, divide by the derivative of the bracket, which is 4x. Now the reason why I can do it straight away like that is because I know that the x parts are going to cancel out. Okay, so this is a shortcut quick way, and we have the answer is 1/3 2x squared plus 5 to the 3 plus c. Question 3. I'm going to write down the 6x plus 5. Okay. You can put an extra step in because I know that this is 3x squared plus 5x to the half, but I'm not. I'm just going to go straight for it. 3x squared plus 5x to the half becomes to the 3/2. Divide by 3/2 is times by 2/3, but also divide by the derivative of the inner, which is 6x plus 5. The 6x plus 5 cancels here, and you've got a final answer, 2/3 into 3x squared plus 5x to the 3/2 plus c. Okay, I'll do a few more. I'll keep going. In fact, I'll do them all. I promised I'd do them all. Let's just see the speed we can get on these last 3 here. That might copy all the page actually. Let's see what it copies. Copies them all, that's fine. The last 3 are here. So here we go. I might just take this steady a little bit just to put one more stepping stone in here. So 5 is the integral of 2x plus 3 times by x squared plus 3x plus 1 to the -2 dx. Okay, alright, off we go. Leave the 2x plus 3 where it is, times by x squared plus 3x plus 1, increase the power by 1, -1, divide by the new power, divide by the derivative of the bracket, cancel, cancel, equals to -1 over x squared plus 3x plus 1 plus c. Okay, let's do 7 now. I can just go straight for this, I think. You know, the answer is the 8x cubed minus 4x. We'll leave that where it is, and that's times by the x to the 4 minus x squared cubed, but then we increase the power by 1, my bad, 4, divide by the new power, 4, divide by the derivative, 4x cubed minus 2x, okay? I'm going to take out a factor of, well, we can actually take this out and make them the same, can't we? Let's take a 2 out of this numerator here, and then we make it into 4x cubed minus 2x, which cancels with this, and we've got a final answer is 1/2 x to the 4 minus x squared to the 4 plus c. I lied, I'll just do the 4, okay? Now let's just do this one again using integration by substitution, okay? So question 7 again is here. We're going to integrate. Our brain's not going very well here. Let's have a little look. Oh, actually, look. I forgot I zoomed in on the page, so it's very small. So I can do 7 again using integration by substitution, alright? So here's integral of x squared. Was that 7? That was 9. Ah, interesting. I am going a bit crazy. That was actually question 9. So let's do 9 using integration by substitution. So we've got the integral. I'm going to put let I equal the integral of 8x cubed minus 4x into x to the 4 minus x squared cubed dx. Okay, that's right. Yep. And now I'm going to use a u substitution. Okay, so always let u equal the g of x. Okay, it's the inner function. Okay, the f of g of x, which I mentioned before. I'm going to let u equal x to the 4 minus x squared. Okay, now we're going to differentiate that. Du by dx equals to 4x cubed minus 2x. Okay, 4x cubed minus 2x. Now here's the thing, we've got to replace everything in terms of x on the original integral and the dx with u's and du's. Okay, so you can do this in a variety of ways. I'm going to write down I here. Okay, so the integral of, well, 8x cubed minus 4x squared, I'm going to put that as 2 into 4x cubed minus 2x. Okay, that's the first bit done, the integral of. The x to the 4 minus x squared is u, so that's u cubed, and then I've got dx here, okay? But can you see I could replace the dx, because I've got a dx actually over here. So I could rearrange this, and we can separate the variables here. We're treating these as small increments, so du by dx is a small change in u, small change in x, and we can separate the variables here. That's perfectly allowed. So if I did separate the variables and just wrote it down in a different colour pen, then I could say that dx is replaceable by du over 4x cubed minus 2x. Alright, so I would then go to here and replace the dx with du over 4x cubed minus 2x. This guy cancels with this guy, and can you see we've got a simple integral of 2u cubed du. It's taken me a long time, but the answer for this now is 2u to the 4 over 4, which is a half u4. So the answer is a half u to the 4 plus c. That's the answer to the integral. But what was u representing? Well, u represented what was it, x to the 4 minus x squared. So this is a half x to the 4 minus x squared all to the 4 plus c. But that's exactly the same answer that we got about 10 hours ago by doing by inspection. Same answer. So it's a lot super quick, okay? So compare and contrast. By substitution does work for all of these questions, definitely. Just takes a bit longer, but then you have to choose let u equal which part, and so you need to let u equal the g of x. But if you're already identifying which function you make u equal to, you've already identified that the derivative of that appears as the other piece of the integral. And if that's the case, you can always do it by inspection. As we move on to harder integrals, integration by substitution becomes a really powerful technique to use when things don't work out quite so smoothly. Okay.